Welcome! We're going to practice more with our polynomial operations through this Unit 13 study guide and make sure that we are super prepared for that upcoming test. So, number one, we're going to work with our adding or subtracting. Number one, we can see that we have a binomial two terms added onto another binomial of two terms. Remember that you can only add or subtract with like terms. Anytime that you add or subtract, this is like terms only. So my 5a squared and my 8a squared are like terms. The variable and the exponent matches in both of those. So I can add my coefficients. 5 plus 8 is going to put us at 13. And then with the exact same variable pattern, a squared stays the same. Next up, I see that I have a constant -3 and also a constant value of -1. These are being added again. So -3 plus -1 makes -4. There is our simplified answer. No more like terms that we can combine. So as I move on then to part B, I can see that I have multiple terms here. Go ahead and find the like terms in this, and recall that your standard form is going to want you to go from the highest exponent to the lowest exponent. So as I look through here, a 2 exponent, an invisible 1 exponent, a 3 exponent, 2 exponent, and no exponent at all on that constant term. So start with the largest, that's 6p to the third, and I do not have any other terms to combine with that, so it will stay the same. Next, I'm going to go after my 3 exponent, see if we have any 2 exponents. That's a 4p to the second, and then also a -7p to the second. Use those signs. So a +4 plus a -7 puts us at -3 with the same variable, p squared. Continue on down the row, then I look for p to the 1, so here I have a -8p with that invisible first power. There's no other p's to the first power. That will stay exactly the same, -8p, and remember, we don't have to write that exponent because it is an invisible 1. Lastly, any other terms that we haven't used? And so I'm looking at this +12 constant, no other constants to combine with it, so we keep that just the same. Here is our simplified polynomial. And then part C, notice that we have a trinomial minus a trinomial. With that minus, you're thinking about it being a -1, and we have to distribute that -1 through to every term in that next set of parentheses. So my -1 times -13 makes +13 with the same b squared. Then -1 distributes to -5b, so negative times negative is going to give us +5b. And that -1 again multiplies to the +14. This makes -14. Bring down everything from that first set of parentheses, the 9b to the third minus 13b squared plus b. All of these are what we're going to be left with to combine. Again, thinking in standard form, I'm going to start with my highest exponent. So that is this 9b to the third, and I do not have any other items to the third exponent. So we'll keep that just the way it is. After that third exponent, I'm going to go looking for second powers, exponents of 2, so that's a -13b squared, and a +13b squared. Well, look at that. -13 plus +13. These are inverse terms. When you add them together, they're going to cancel out with each other. They're going to add to a 0, so I don't have to worry about that. So now, after that second power, I'm going to go on and look for first powers. So I've got this b to the invisible 1, and I've got that 5b to the invisible 1. So think about that coefficient here on that positive b. You have an invisible 1 coefficient with it. So your job is to think about a +1 plus a +5. That makes +6 with the same b variable. And then lastly, my constant here is a -14. I don't have any other constants, so we'll keep that exactly the way that you see it. That is adding and subtracting. It's all about focusing on only adding the like terms. Those variables have to match before you add, and then the variable has to match in the answer as well. The next section here with that number 2 wants you to practice with multiplying or dividing. Excuse me. So as you look at the part A, There's one item, one term out in front of the parentheses, so we're going to distribute x times 2x squared. So invisible coefficient of 1 times coefficient of 2 makes 2. And then with my x variables, x times x squared, remember your exponent rules. When you multiply the variable, when you multiply the base, you add the exponent. So invisible exponent 1 is now added on with exponent 2. This gives us x to the third. Next term then, that 1x is being multiplied by the negative 3. So coefficient 1 times coefficient negative 3 makes negative 3. And my x times my x, again, I'm adding the exponents. Add the invisible 1 with the invisible 1. That makes it x to the 2. And lastly, that x is going to multiply with my third term, then positive 9. So this is a positive 9x, a variable times a number. They just get super glued together. Do you have any like terms here that you can combine? X to the third, x squared, and then lastly an x? Nope, these are not like terms. Everybody has a different exponent, so this is where we leave it. So when you multiply, you can change the exponents. When you multiply, as you multiply bases, add the exponent values together so you can come up with a new variable term. Over there on on the letter B, again, one term outside the parentheses, we're going to distribute to all the terms inside. How many terms inside the parentheses? 4 of them. So you're going to multiply 4 times through that. So negative 5b to the third times 4b to the fifth. So coefficients, negative 5 times 4 makes negative 20. And when I multiply my b's, add those exponents. 3 plus 5 makes it 8. Then my next term, negative 5b to the third times negative 2b to the third. So negative 5 times negative 2 for my coefficients makes positive 10. B to the third times b to the third. When you multiply the bases, add the exponents. 3 plus 3 puts you at a b to the sixth. Multiplying again, negative 5b to the third times that b. So negative 5 times invisible 1 makes it negative 5. And b to the 3 times b, when I multiply the bases, add the exponent 3 with the exponent invisible 1. That makes b to the 4. And lastly, I've got to multiply by my final term. So negative 5 times negative 11 makes positive 55. And b to the 3 times no other b's, so that variable stays the same. Here is our final answer because every term has a different exponent on b, so nobody else is a like term, nobody else can be added together. Now, as we come along and look at that part C, notice that it is a binomial times a binomial. My first term is going to need to multiply to both terms in the next set of parentheses. So we'll do 7c times 11c. Just like we distributed earlier, 7 times 11 for my coefficients makes 77, and c times c makes it c squared. Remember, as you multiply those c's, you are adding their exponents. So the invisible 1 plus invisible 1 exponent made a 2 exponent now. We're going to take that same 7c term and multiply it by the other term in the other parentheses. 7c times negative 3. So 7 times negative 3 is negative 21. Keep that c because there were no other variables to multiply it with. Now, I've got this positive 5 term. That first set of parentheses had 2 terms. Every term in there has to multiply through the other parentheses. So we're doing positive 5 times 11c. So positive 5 times 11 for positive 55c. And then positive 5 times negative 3 makes negative 15. Do you have any like terms in here? Well, yes, we do. A term with a c and a term with a c. That's what we're looking. So negative 21 plus 55 is going to give us positive 34 with the same exact variable pattern. Those were like terms. They had to match in order to add them together, and their sum, that result, has to match as well. Bring down the other stuff. Nothing else changed there. 77c squared, didn't have anybody else to add with. Negative 15 didn't have anybody else to add with. This is our final answer. Right down below that with our line for D. And so I've got 2 terms in a binomial times 3 terms of a trinomial. So each one is going to have to multiply. So w times w squared to start us off is w to the third. When we multiply, we add the exponents. W is going to have to multiply down to the negative 5m. This is negative 5mw. And then w multiplies all the way down to the positive 4. This is positive 4w. Then continue on along. Next term, positive 6m. So that positive 6m has to multiply by w squared. So positive 6m w squared. Now that positive 6m multiplies to our negative 5m. That makes negative 30m squared. Again, when you multiply those two m's, add their invisible exponents. And lastly, that 6m is going to multiply with the positive 4. This makes positive 24m. Look for your like terms now. Are there any like terms in there? Nope. It seems that everybody has a different exponent and variable pattern. So this is exactly what you could leave as your answer. There is a chance that maybe you wanted to rearrange your terms a little bit to move the w squared up front closer to the w to the third. But since you have 2 different variables going on in there, sometimes it's hard to determine that standard form about its ordering, so that's okay. All right, now as we look at part E, I know I went into its box a little bit, so I'll work with that down below because part D certainly had a lot of multiplication going on. But I know that you handled it like a champ. So with these 2 binomials that we're multiplying here in E, my 2x times my 2x is going to be 4x squared. And then my 2x times the negative 4y is negative 8xy. Now some more multiplication happening in there. The positive 4y times 2x. Positive 4 times 2 is positive 8. Same, and then xy. And positive 4y times negative 4y. So positive 4 times negative 4 is negative 16. Y times y makes y squared. Do you have any like terms in here? Well, I see a negative 8xy and a positive 8xy. Negative 8 plus positive 8. Oh, those are going to be inverses. They end up canceling each other out. So what are we left with then? 4x squared minus 16y squared. That is our simplified polynomial. So as you see that part F, check it out. A set of parentheses with a binomial that's raised to the second power. When you see those parentheses to a power of 2, you gotta write it twice. When you see those parentheses with an exponent of 2, you've gotta write it twice. So what happens now that we've written it twice? This clues you in that you've got to do that double distribute, exactly like we did in C and E and even D. So make sure that any binomial with an exponent 2, you have to write it out twice so that you can double distribute. 2k times 2k makes 4k squared. 2k distributes down to the positive 3 for positive 6k. And moving right along, now my positive 3 multiplied by 2k is going to be a positive 6k. That positive 3 also multiplies with positive 3, and we're going to get positive 9. Look for like terms. Do you have like terms in here? Positive 6k and positive 6k. Yeah, we can add those together. That's a positive 12k. And bring down anything else that didn't have a like term. 4k squared is coming on along, and positive 9 is coming on along. Here is our simplified polynomial. It's looking great. So down here at the bottom, this last row wants us to look at our division rules a little bit. So we're going to have to divide each term. Okay, so I'm going to start out with 30 divided by 6, coefficients first. 30 divided by 6 puts us at 5. And when we divide these variables, remember that we subtract the exponents. So d to the fourth divided by the d squared, 4 minus 2 on my exponents is going to leave me with 2. And then look at those f's. F to the 8 and f to the 9. 8 minus 9 is an f to the negative 1. So next term, we've got a negative 12 divided by a 6 for our coefficients. That's negative 2. My d to the 3 divided by that d to the 2. When you divide the variables, subtract the exponents. 3 minus 2 there makes it 1. And with those f's, f to the 6 divided by f to the 9. So 6 minus 9 is f to the negative 3. Last term then, we've got a positive 6 divided by a 6 for my coefficients. That's a positive 1. D to the 2 divided by d to the 2. So 2 minus 2 for that variable is a 0. Yeah, that's going to cancel out, right? Anything divided by itself simplifies to a 1. And f to the 9 divided by f to the 9. Anything divided by itself cancels out there for it. So I've got a 1 for that term. I hope you remember those exponent rules where you were never allowed to leave a negative exponent in your answer. So yes, we do need to do a little bit of rewriting and reworking on some of this. Imagine that first term already is over a 1, and so the 5 is happy as it is, the d squared is happy as it is, but that f to the negative 1, negative exponent there, has to switch sides of the fraction bar. Then, with that next term, it's already over a 1, so I am subtracting that. My 2 looks just fine as it is. The d looks just fine as it is, but the f needs to switch sides of the fraction bar to become a positive 3 exponent there. And lastly, we've got that positive 1 tagging along. It doesn't have any variables left. There's no negative exponents to be seen. This is what we're looking for, that simplified form. In H, I'm going to go ahead and rewrite this format on H here to get started. We are dividing our trinomial by 3r to the third. And for me, it just is easier to think about in that fraction format. So I'm just going to rewrite it instead of having that division at the end. I will put that in at the beginning. So now 3r to the fifth is divided by 3r to the third. So coefficients, 3 divided by 3 is 1. R to the 5 divided by r to the 3. Subtract those exponents. 5 minus 3 makes it 2. Next term, a negative 12r squared divided by the 3r squared. So negative 12 divided by 3 is negative 4. And r squared divided by r to the 3. Subtract your exponents. 2 minus 3, you're looking at r to the negative 1. Lastly, negative 15r divided by the 3r to the third. So negative 15 divided by 3 for your coefficients is negative 5. And then r to the invisible 1 exponent divided by the r to the 3. So we're going to take 1 minus 3 for those exponents and make it r to the negative 2. So a little bit of stuff that we can clean up here. In our first term, we have an invisible 1 coefficient. We don't need to write that anymore because we already know it's invisible. In our second term, recognize that you have a negative exponent, so we have to switch the side of the fraction bar. Right now, everything's in the numerator. So we're going to keep that positive 4 exactly where it is, but the r to the negative 1 is going to have to switch to the denominator to become a positive 1, and that's an invisible exponent that we don't have to write down. The last term also, I see a negative exponent in it. Remember, everything here is already in the numerator, so we'll keep that negative 5 just where it is, and then the r to the negative 2. Remember, that's all that your exponent's working on, so that moves to the denominator to become a positive 2 exponent. Here's what we're looking at for the final simplified version. Then, part I, we jump into here, and all the pieces that are going to divide. So we're going to take 30 divided by 60, and that is 1/2. H to the fourth divided by h to the invisible 1 exponent. So you're going to subtract 4 minus 1. Anytime that you divide, we subtract those exponents. 4 minus 1 makes it 3. My next term then, we've got this negative 24 dividing by the 60 there for my coefficients. That doesn't divide evenly, but you can certainly simplify that fraction. I'm going to get -2/5. And h to the third divided by h says subtract the exponents 3 minus 1. So this is now h to the 2. Last term, +6 divided by 60 for my coefficients. That can certainly simplify. This is a +1/10. And then h squared divided by h. So 2 minus 1 puts us at h to the invisible 1, but I'm not going to write it because it's invisible. And I don't have any negative exponents. All of my terms have different exponents, so no more like terms. This is where we would end. So as you flip over there and find your question number 4, we want to simplify completely here. Now notice there's a little bit of more complex problems going on. So you want to keep your order of operations in mind, right? Parentheses, exponents, multiply, divide, and then add, subtract. And when we talk about parentheses here, we're saying do what's inside of the parentheses. So we're saying take that m squared and subtract the m and add the 2. Well, we already know we can't do that because nothing in those parentheses are like terms. And when you look at that next set of grouping symbols, right, the parentheses down here, a 10m and a +7, can they be added? No, they're not like terms. So there's really nothing you can do about those grouping symbols. And the exponents are asking you if you can square something. We have exponents written, but they're not doing something for us, but they're just identifying what the terms are, who's alike and who's unlike. So then you have to multiply or divide. That's next up in your list. Multiplying or dividing is where we got to go. So that first set of parentheses is going to need some multiplication because we are distributing. 2 times 4m squared makes 8m squared. 2 times -m makes it -2m, and 2 times +2 makes it +4. I've got this -3m squared hanging out here. Nothing else happened with it. Bring it along for the ride. And then that +2m is going to need to distribute through. So +2m times 10m makes +20m squared. And the +2m times +7 makes +14m. So then we go ahead and we search for like terms. 8m squared and -3m squared and 20m squared. They all have that m squared, so we just add those coefficients. The 8 plus the -3 would make it 5, and then we're going to add on the 20. This puts us at 25 with the exact same m squared. Look for more like terms in there. I've got a -2m and a +14m. -2, +14. This is going to be a +12 with the same m. Lastly, I see a +4 constant, no other constants around, so that'll stay the same. There's our simplified polynomial. Part B, again, is going to ask us to have a similar thought process going on. The parentheses are saying, can you simplify inside of them? An r squared and a constant doesn't subtract. An r and a constant doesn't subtract. Well, here I have an r minus an r. Those are like terms, so I can simplify here. 8r and -r would make this now a 7r plus 4 within that set of parentheses. Everything else is going to stay the same and come along for the ride. Okay. Now, the exponents part of your order of operations, are there any exponents to apply? Are there any values here where you can square? No, the exponents that I see are identifying my like terms or not like terms. So then we get to the go ahead and multiply or divide phase. So we're going to multiply. My first multiplication comes from a binomial times a binomial, so we're going to double distribute. 5r squared times 2r makes 10r to the third. 5r squared times -3 is -15r squared. Then I've got the -7 as my second term. That's going to distribute to 2r. That's -14r. That same -7 multiplies to the -3 for +21. And I've got this negative 6r squared in all its glory. That's got to do some multiplication as well. It also has a set of parentheses to multiply through. So negative 6 times 7 is negative 42, and r squared times r, add the exponents for r to the third, negative 6r squared, and times that positive 4 is going to be a negative 24r squared. Do you have any like terms? That's what we're looking for now. So I've got an r to the third and an r to the third that we can work with. So 10 minus 42 would put us at negative 32 r to the third. Then I've got an r squared from this negative 15 and an r squared over here at that negative 24. So the negative 15 and the negative 24 add together. That's a negative 39 with the same r squared. And look at what else is happening then. I've got this negative 14r. There's no other r's. That comes along for the ride. There's this positive 21, no other constants, so that will stay the same. Here is our simplified polynomial, and notice we did get that answer in standard form: 3 exponent, 2 exponent, invisible 1 exponent, and then no variables at all. So number 5 wants us to write an expression about how much fencing is needed to enclose the horse pasture. If you're thinking fencing, hopefully you are thinking about perimeter. And how do you find the perimeter? We are going to add all of the side lengths. So I'm going to pick a side length to start at here, 5y minus 2, and then I will add on the rest of my sides, the y plus 3. Add on the 3y minus 8, add on the 2y minus 1, and add on the y plus 5. So with all of that addition now, we're going to look for like terms. So 5y is like terms with y, that's an invisible 1, is like terms with 3y, is like terms with 2y, and is like terms with y. It also has an invisible 1. So we're going to do 5 plus 1 makes 6, plus 3 makes 9, plus 2 makes 11, plus 1 puts us at 12, still with the y. And for the constants, negative 2 plus 3 makes positive 1, plus a negative 8 puts us at negative 7, plus a negative 1 makes negative 8, and then plus a 5 puts us at negative 3. So we're talking about 12y minus 3 units of fencing. And now the question didn't specify, but those units could be feet, they could be centimeters, they could be miles, but whatever y is, 12y minus 3 will tell me what that perimeter, what the fencing amount is. Number 6 wants me to write an expression to represent the area of the rectangle. So area of a rectangle, sometimes you see it written as length times width, sometimes you see area of a rectangle written as base times height. They're both doing the same thing for you there. So I'm going to take my one side, 2x plus 2 as my length, multiply that by the width, 4x plus 3. So when you look at this multiplication problem, binomial times binomial, you've got to recognize we need to double distribute. So 2x times 4x makes 8x squared. And then 2x times the positive 3 for a positive 6x. Move on to that next term. 2 times 4x is going to be a positive 8x. And 2 times 3 gives me positive 6. Look for any like terms that you might have going on in there. And I see a little bit of like terms here with the x's. So the positive 6 and the positive 8. Whoops, I've lost my addition sign there that it was. Okay, so positive 6 and positive 8 there makes positive 14x for us. And no other like terms. The 8x squared comes along, the positive 6 comes along. So here is our area, and this is going to be represented in square units. Area is always square feet, square miles, square meters, square centimeters, whatever it is. I'm talking square units here. So I hope that you feel so much more confident and proud of all your hard work with polynomials. Good luck on that upcoming test.